Hello guys, welcome back to my channel. In this particular video we will learn about the laws and naming reaction of aldehyde ketone and carboxylic acid. For that you must be ready with your pen and copy, and please follow me what I am doing on the board. So today we will start with our first reaction, which is known as Rosenmund reaction. In this reaction what happens, acetyl chlorides are converted to corresponding aldehydes by catalytic reduction. The reaction of acyl chloride in the presence of palladium deposits over BaSO4 partially poisoned with sulfur or quinoline. Acyl chloride gets reduced to aldehyde by catalytic decomposition or catalytic reduction in the presence of palladium or BaSO4, which is poisoned with sulfur or quinoline. For example, if we take the acyl chloride group with RCCl double bond O plus H2, which is passed through PD, which is palladium, BaSO4 and sulfur, poisoned with sulfur, it gives aldehyde RCH double bond O plus HCl. So this is what we have learned here. In place of R, you can put any of that acyl group over there to get the desired result. So now we will move on to our next reaction, which is known as Stephen reaction. In this reaction what happens, the reaction in which nitriles are reduced to corresponding imines with SnCl2 in presence of hydrochloric acid HCl, which upon hydrolysis gives corresponding aldehydes. Nitriles converted to corresponding imine with SnCl2 in the presence of hydrochloric acid, which upon hydrolysis gives aldehydes. For example, if we take SnCl2 plus 2HCl, which gives SnCl4 plus 2 nascent hydrogen, which is not stable obviously. Another example we can take CH3C triple bond N plus 2 nascent hydrogen plus HCl gives CH3CN double bonds NHCl, which is known as acetyldoxamine hydrochloride, which upon hydrolysis steam gives CH3CHO, which is known as acetaldehyde plus ammonium chloride NH4Cl. The H2O taken between is for hydrolysis. Now we will move on to our next reaction, which is known as Gattermann-Koch reaction. In this reaction, hydrogen chloride in the presence of anhydrous AlCl3 CuCl gives benzaldehyde. When benzene is present, so benzene when passed through HCl hydrogen chloride in the presence of anhydrous AlCl3 and CuCl gives benzaldehyde or a substituted benzaldehyde. So it is one of the easy reaction where benzene gets converted into benzaldehyde. This Gattermann-Koch is used in multiple times in conversions, where the question asks you to convert benzene to benzaldehyde. So here is our reaction. Benzene passed through CO, HCl, anhydrous AlCl3, CuCl gives benzaldehyde. Now we will move on to our next reaction, which is known as Clemenson reduction. Clemenson reduction, in this reaction what happens, the carbonyl group of aldehyde ketone, basically carbonyl group contains aldehyde and ketone only. So when carbonyl group is reduced to CH2 group, which upon treatment with zinc amalgam is when zinc is pyrated with some other metals, it is known as zinc amalgam. Like cobalt or nickel is given in small quantity, it is known as zinc amalgam, and concentrated hydrochloric acid, the reaction is known as Clemenson reduction. So if we take an example that carbonyl group when passed through nascent hydrogen, 4 nascent hydrogen, using zinc amalgam and concentrated HCl gives CH2 group plus water as a byproduct. Another reaction, if we take CH3CH2 CH2CHO plus nascent hydrogen which passed through zinc amalgam and concentrated HCl gives CH3CH2 CH3, which is known as N-butane. The first one is which is given CHO, it is known as butanol, whereas the last one is known as N-butane. So here it is, our Clemenson reduction. Now we will move on to our next type of reaction, which is known as Wolff-Kishner reaction, which is very important in terms of exam. In this reaction what happens that when carbonyl group of aldehyde and ketone, reduced to CH2 group, here it is also converted into CH2 group, but what happens, it is different from Clemenson because it is treated with hydrogen followed by heating with potassium or sodium hydroxide in a followed by heating with potassium sodium hydroxide, that is NaOH KOH, in a highly boiling solvent, such as ethylene glycol. So if we take a generalized equation for this, carbonyl group when reacted with hydrogen, that is NH2 single bond NH2 hydrogen, which when reacted loses its water molecule, it gives hydrazone, that is C double bond NNH2, which further reacted with sodium or potassium hydroxide and ethylene glycol gives CH2 group and nitrogen. Hope you guys enjoyed this video. If you haven't subscribed our channel, please go to the YouTube section, search study with like and subscribe us, and thanks for watching till the end.